Hello, calculus students. Today we're exploring a key concept for understanding the long-term behavior of functions, horizontal asymptotes. In simple terms, a horizontal asymptote is a horizontal line that a function's graph gets closer and closer to as x goes to positive or negative infinity. Consider this function. As we move far to the right, meaning x gets very large, notice how the graph flattens out and approaches the value y equals 2. Similarly, as we move far to the left where x becomes a very large negative number, the graph also approaches y equals 2. This value, y equals 2, represents the horizontal asymptote. It describes the function's end behavior. In calculus, we use limits to define this formally. The limit of f of x as x approaches infinity is a finite number, L. Or if the limit of f of x as x approaches negative infinity is L, a function can have up to two different horizontal asymptotes. Horizontal asymptotes appear in many real-world scenarios. Let's look at medicine. Imagine a patient receives a drug through a continuous IV drip. The concentration of the drug in their blood, C, over time t, can be modeled like this. Cmax is the maximum concentration, and K is a constant. What happens after a very long time? We take the limit as t approaches infinity. As time t gets infinitely large, the exponent negative kt becomes a very large negative number. An exponential function with a large negative exponent gets extremely close to 0, so we substitute 0 into our limit. The limit is Cmax. This means the drug concentration will level off and approach a steady maximum level, which is vital for determining safe dosages. Now let's consider economics. A company has a fixed cost F and a variable cost per item V. The average cost per item, A of x, is the total cost divided by the number of items, x. We can simplify this by splitting the fraction. What happens to the average cost if the company produces a massive number of items? We take the limit as x approaches infinity. As x gets infinitely large, the fixed cost F is spread over more units, so the term F over x approaches 0. The limit is V. This means the average cost per item will never fall below the variable cost V. This is a key idea in economies of scale. So let's recap. 1. A horizontal asymptote describes the end behavior of a function, what value it approaches as x goes to infinity. 2. It's formally defined using limits. The line y equals L is an asymptote if the limit of f of x is L. And 3. They model real-world limits and steady states in fields like medicine and economics. Understanding them gives you a powerful tool to analyze the long-term trends of complex systems. Thanks for watching.